Hello, today we're going to look at graphing polynomials. And really, before we even begin trying to graph any of it, we need to start looking at the equations and seeing how different variables in the equations affect the graph. So that's what we're going to start at, is looking at some patterns I've set up here for you. And these are the first four graphs. Now notice these are quadratics. And what I want you to do with these is just take the equations that you have here and factor them. Okay, and do the same for number 5. And let's look at, I've got several more here. Now these are not quadratics, but I still want you to look at these. These are still polynomials. And we're going to factor number 6 and number 7. Oh, wait a minute. Number 7's already factored for you. So that's nice of me. And let's look at number 8 through 11 here. Those are factored, so you don't actually have to worry about factoring these. Just factor numbers 1 through 6, and then we're going to look at the zeros on these functions, okay? So you take a moment and try that out. All right, I've taken it that you have paused the video and factored those. I'm going to show you the answers now. What I got for number 1 was x minus 3 and x plus 1. Number 2, x minus 3 times x plus 3. Number 3, I got x plus 4 times x plus 4. Number 4 did not factor. Remember, that is a sum of cubes, a sum of squares, not a difference of squares. We can't factor a sum of squares. And then down here I've got, for this one, x minus 3 times x minus 3 for number 5. Number 6, I factored to x minus 1 times x plus 1 times x minus 3. Now on these, I understand that maybe you're wondering like how I factored some of them. This is not a video on factoring, so what I'm going to do is just kind of show you my work, and you can pause the video if you need to and go through that. This is number 1, number 2's work, number 3, number 4, remember, did not factor. Here is number 5 in blue, light blue. And for number 6 right here, this is one that we don't really factor that often. So just to kind of walk you through that, I did group these two right here together. So it's like I wrapped the first 2 in parentheses and wrapped the last 2 in parentheses. And from there, I factored out what's in common, the x squared here. I got x minus 3 in the middle. To make this look like this right here, I factored out a negative 1. And then I factored out x minus 3 right here, so I end up with x squared minus 1 times x minus 3. Now don't forget that this also can still be factored because it is a difference of squares, and that factors into x minus 1 times x plus 1, and then of course the x minus 3 comes down right there. So that is number 6 factored. Now I want you to pay attention and note that there is a difference here between what are factors of a function and what are the zeros of the function. What we just did was factor them. So we came up with factors of the function. If I want to find the zeros, well, I'm asking what makes the function equal to 0. Let's go back to number 1 here. So I want to know where the zeros are. Pretend like we don't already have the graph, because that's cheating, right? So if we're just given the equation and said, find the zeros, well, that's when we say, let the function equal 0 and see what value for x makes it equal to 0. So we factor, and when we get to this point, we say, okay, we've got x minus 3 equals 0 and x plus 1 equals 0. And so our zeros are at 3 and negative 1, which is what we have right here on the graph. 3 and negative 1 are my zeros, okay? So that all checks out. Let's keep going and look at the other zeros. So for number 2, you can set each one equal to 0 and solve, but eventually we start realizing that, hey, this is set up so nicely for us because this equals 0 when x equals 3. It's pretty, I think most students can catch on pretty quickly, and if you don't immediately see what makes it equal 0, you can set them each factor equal to 0 and solve. Now this one is repeated, right? So it's repeated twice. And another word for that repeated factor is we call that a multiplicity. It has a multiplicity of 2. So you don't have to set both equal to 0 because once you solve for one, you got the other one. This is x equals negative 4. And you say, okay, notice on the graph here for number 3, it only crosses the x-axis at one point, or it doesn't really cross it, it just touches it, right? But it only hits that x-axis at one point, and that's at -4. And so the other one we don't, it's just a multiplicity of 2. It has its value, and we'll see that in a moment. Let's look at our other one we factored here. Number 5, and once again, it's repeated twice. It has a multiplicity of 2. And solving for when this function equals 0, we end up with x equals 3 will make the function equal to 0. A reminder here, I can put 3 in right here and see it goes to 0. Or if I put 3 in right here, I get 9 minus 18 plus 9 when I substitute in 3, and I still get 0. Okay, it doesn't matter because they are, this factored form is equal to the original standard form up above it. Now this one has 3 factors. Number 6 does. So we end up with zeros at x equals 1, x equals -1, and x equals 3. Please pay attention to the wording here. When I'm asking for the factors of a function, we're going to get x minus something, x plus something. I want to know what are those factors that will multiply to give you the function. When I'm asking for the zeros, it's going to be x equals a number. So you take the factors, set them equal to 0, and then solve it. It's not always a binomial factor. Sometimes you can factor out x by itself, and just one of the zeros is just 0 itself if it crosses at the origin. So let's go back and look at number 4 real fast, because number 4 did not factor. Remember, this one did not factor, and notice we don't have an x-intercept here. So let's see what happens if we actually set this function equal to 0. If I say, all right, you know what, I know it didn't factor, but let me just set that function equal to 0. What x value will make the whole function equal to 0? Well, if I subtract 4 from both sides, I get x squared equals -4. Square root both sides to get x by itself, and I get x equals the square root of -4. Oh, and now we don't have a real number right here because we can't take the square root of a negative number. We're getting into the imaginary numbers, and we're not dealing with that right now. So notice this one does not have an x value that will make the function equal 0, which makes sense because the range of the function does not include 0. It's from 4 and on up, right? So the range goes from 4 to infinity, does not include a y value for 0, so we can't really, that one's done. But anyway, so with that being said, let's look at our zeros here. I want you to, I can't talk today. I want you to take a note that we've got x equals -1, x equals 3 right here on the first one. And notice that it just goes nice and easy through the x-axis. Same thing right here. We end up with -3 and 3. Those match up. Everything matches up here. Let's look at our back, though. Our second page to this. We have 3 zeros right here. We've got -1. We've got +1 right here. So this gives me a 0 of +1, -1, and then +3 right here. And that's where they're crossing. And then these other ones I already factored for you. Notice that if we find the zeros, I've got zeros at x equals 1 and a 0 at x equals 3. Go ahead and go through and find all the zeros based on the factors I give you. I'm going to pause it and show you the answers. All right, I take you went through the rest of it and you found the zeros based on the factors I gave you. Let's go back and look at those just to make sure that we're all got the same ones. I got x equals 1 from that, and then x equals 3. -2 from these two factors, and then 1 right here. -3 from the x plus 3, 1 and 2. And then down here we've got -3 and 1 and 1. And this is my pen kind of smudged here, but that is a 4 going to those right there. So with that, let's look and see a couple of things about the actual graph and what's going on. So here, notice the x minus 1 repeats itself, but the x minus 3 does not. Over here, x plus 2 repeats itself, the x minus 1 does not. By the way, you don't have to write down that -2 twice. Even though it's written twice, you only got to write it down once. It only crosses in there at one time, X plus 3, oops, I shouldn't have underlined that. It's just one time, right? Nothing repeats here. Over here, x minus 1 repeats. and then right here, x minus 4 repeats. I want you to take a look at where it repeats and what's going on the graph at that intercept versus when it doesn't repeat and what's going on. Make a prediction about the repeating. All right, with that being, hopefully you had a chance to make a prediction there. X minus 1 and x minus 1, look at what's going on here. X minus 1, it does not cross the x-axis. It does what I call bounces. So it's repeated twice here and it bounces. What about the x minus 3? At x minus 3, and when x equals 3, it goes through the x-axis. Switch down here. You've got a repeat, it bounces. Non-repeat, it goes through. What about over here? X plus 3 doesn't repeat. It goes through at negative 3. It goes through at 1. It goes through at 2. None of these repeat it, and it goes through. X equals negative 3 goes through. X equals 1, it bounces there. See how it comes down to the x-axis and bounces up. There's a repeat here. And then over here we got when x equals 1, it goes through. The factor's only listed once. Here it's listed twice, and it bounces. So this might make us start to think, if it repeats, it bounces. And if it doesn't, it goes through. But don't come to that conclusion just yet. Hopefully you're watching this thoroughly and not just stopping the video there. Let's go over to Desmos and let's type in something like the one we just had. X minus 1 times x minus 4 times x minus 4. So x minus 1 times x minus 4 times x minus 4. So there's our graph. Notice our zeros. We've got one right here and one right here. Now, I'm going to throw in another x minus 4 right here. So let's put that in there, x minus 4. Now look what happens here. Notice it does not bounce. It goes through. See? I'll erase this. Goodbye. Now it bounces. Put that back in. X minus 4. And it goes through. Let's put in another x minus 4. Now it bounces. In fact, instead of writing out, let's go back to the beginning here. And we're going to look at this pattern a little more in detail. Instead of saying x minus 4 times x minus 4, what I'm going to do instead is, that's the same thing as saying x minus 4 quantity squared. So I'm going to get rid of this and just make it squared like that. So there we have it, x minus 4 quantity squared. This means, we can rewrite out x minus 4 squared as x minus 4 times x minus 4 if we wanted to. But here's a quick, easy way to see the multiplicity of it. If it's raised to the power of 2, the multiplicity is 2, right? If it's raised to the power of 3, the multiplicity is 3. That means that the x minus 4 factor shows up 3 times. If I make it 4, that means the multiplicity is 4. We could rewrite that as x minus 1 times x minus 4 times x minus 4 times x minus 4 times x minus 4. That x minus 4 can get listed 4 times. I just simplify it by writing it to the power of something. And what we're going to do here is look at the pattern. So instead of saying x minus 4 raised to the 4th, I'm going to change that 4 to a variable and we'll call it a. So we can add a slider here. So on this right here, we're going to click on that little 10 right there, and that's going to allow me to change the step here. So I want this to not have decimals. I want it to count by ones. So I'm going to say, okay, count by ones here. We're going to start this at 2. And let's go up to, say, 20. And now as I slide this, it goes from 2 to 3 to 4. It's changing this number right here. How many times x minus 4 is listed as a factor? And so at 2, it looks like this. And notice right here where our 0 is, the 0 doesn't change, but it bounces. The graph comes down and bounces off the x-axis. When I change this to a 3, now the graph has changed. The function's changed too. Don't get me wrong. We are changing the function around, but it's now, I want you to see the pattern as far as how many times that factor is listed and what's going on at the 0 right here. So as I move this to a 4, this is now listed out 4 times like we saw a second ago, and it bounces. If we were to make it a 5, it goes through. Switch it back to a 6, it bounces. 7 goes through, and so forth. We can see it switch between bouncing and going through as we change the A value from what? From an odd number to an even number. So the evens, they bounce. The odds there, they go through. And that's what I want you to see with this exercise. So whenever we have that and we factor out something and we're looking at how many times is that factor listed, we are talking about what we call the multiplicity of the function, or at least the multiplicity of that factor. So sometimes we have several zeros with different multiplicities. If that factor is listed an even number of times, it's going to bounce at that 0. If it's listed in an odd number of times, it's going to go through. That's worth writing down. So I'm going to let's look over and write that one down. Go ahead and pause the video, and you can take a look and write this down. It says multiplicity. How many times is a factor listed? If it's an odd amount, graph goes through. If it's an even amount, the graph bounces. Pause the video if you haven't written that down and take the time to write it down. Let's go back to Desmos, and on Desmos I want to put in one more function, and let's do this time x plus 2 times x plus 2 times x minus 3, and we'll raise this last one here to the power of 3 so we don't have to write it out 3 times. Now, I want you to look at something here. I wanted a function that had zeros at -2 and 3. So I made the factors x plus 2 and x minus 3. That gave me zeros here at -2 and 1 at positive 3. I also wanted the graph to bounce at -2. So I listed that factor an even number of times. I wanted to go through the x-axis at positive 3. So I listed that an odd number of times. So you can really start to create your own graphs, because if you want to know if you want the function to have zeros at a certain spot, then you write the factor accordingly. If I want the factor, or if I want the 0 to go through at positive 9, I'm going to make a factor of x minus 9. And then you can decide, do I want that graph to bounce or go through at that x-axis? And if you want it to bounce, you write it an even number of times or raise that factor to an even power. Or if you want to go through, you write it out an odd number of times or write that factor raised to an odd exponent. So that's how we can use multiplicity to manipulate whether or not the graph is going to bounce or go through at the x-axis. Okay? Next time we're going to take a look and see about the end behavior of a function. How can we affect whether the graph is going up at the end or going down at the end? And the same thing when we're reading it left or right. At the beginning, is it going down or is it going up? Okay? Thanks for watching.